Hi everyone. So since we've solved this question using VFS, now we are going to optimize the solution. The follow-up says that we have to use constant extra space. So notice one thing here that for any level, let's say we have completed the process of initializing the next node. Now for every level, can you see this as a singly linked list after connection of next nodes, right? So, at any level n, we have a singly linked list. So we don't need a queue data structure to traverse nodes at that particular level. We can simply traverse using next node. And at any level n, we can, you know, then use a dummy node. And then since it's an imperfect binary tree, then we can use dummy node to build nodes at level n plus 1. And we'll repeat this process until current is not null or we have no nodes left. So let's code this out in an optimal way. We'll do the same check here. If our root is null, we need to simply return null or root. And in the end as well, we have to return root. So now we do our checking. We'll have, let's say, our current pointer pointing to root initially. And we'll do this while our current is not null. So since our current would be null, so we don't need this extra if block, we can remove it. So if my current is not null, let's create a dummy node. So new node, let's initialize this with value 0. And let's say we have a tail node tail, which points to dummy. Now what do we do if my current has a left child is not null? So it means it has a left child at level n plus 1 at whichever level we are. So then I need to say that my tail dot next has to go to current dot left. Okay. And then let's move our tail to tail dot next. And now if we do the same thing for right child as well. So if current dot right is not null, I need to say cut tail dot next is equals to current dot right and move my tail pointer. And then after this, I have to move my current pointer, which will be current dot next, right? And I forgot doing this thing, which is here. I will have this inside my if current is not null, we'll do this, right? So we're going to do this. And this will go inside the inner block. And outside, we have to move the level, right? So how do we move the level? We say current is equal to dummy dot next. So we move to the next level. And then we return the root. So let's run this code. Yeah, this has to be a while loop because we're running that on that level, right? So that's why. So if I submit this, my time complexity is big O of n since we are processing every node once and our space complexity is constant, which is big O of 1. Why? Because we don't use a queue data structure. Rather, we just have our current pointer and a dummy pointer for every level that we are creating. So yeah, this was it from my end. Thanks for watching. Bye.